Greetings, everybody. Welcome to the Evidence and Reasons Academy. This is the academic channel for the Evidence and Reasons organization. It is an organization committed to exploring evidence and reasons for the Christian faith, but part of that entails studying God's creation using the tools of science. And so this lecture series is dedicated to learning chemistry, college level chemistry. In a typical year-long, it's typically studying general chemistry in the United States at the college level will take about a year of school, basically 2 semesters, not quite a full calendar year, but a school year, which is about 8 months. And that would be about 12 hours of study a week if one wants to be really good at it. If one wants to just kind of make it through the class, so to speak, that maybe 3 hours would do. So this is kind of a study session, not a formal lecture. And I find that it makes it a little just more interesting if we can just, that it's not really a formal classroom, but just a place to hang out and talk about chemistry and work through problems together. So with that, I'm joined by James Wouter and Montesquieu. This is great. My second class and more people are here. So James was here the last time and we were covering just introductory chemistry. So I found some exercises that covered the material from the last lecture. And here it is. Let me see if I could share it. Give me a moment here. I'm looking to share my screen. All right. Anyone is free to weigh in as we do these exercises. So the odd numbered exercises have suggested answers. So question 1, explain how you could experimentally determine whether the outside temperature is higher or lower than 0 degrees Celsius without using a thermometer. Any suggestions?
You could see if water freezes.
Very good. Excellent. So let me just check that in the answer key. By the way, everybody, this the entire textbook is free, which is great. It's available online. At the bottom of the screen there, you could see the URL. You can just go to OpenStax and then start Googling for searching for chemistry. You'll find it. It should be easy. Chemistry textbooks can be very expensive, so it's great that that it's available for free. There are answer keys here. So this is a book that would be adequate enough to get one through college level chemistry. Now, some of the books we pay for are, granted, they are better because a lot of money is invested in all the diagrams and just making it very glitzy, so to speak. But I think this is adequate. So yes, the answer is, let me look at the answer key again. Yep, place water in a glass outside. It will freeze if the temperature is below 0. Let's go back to exercises. Okay. Number 2, identify each of the following statements as being most similar to a hypothesis, a law, or a theory. Explain your reasoning. Now, I'll just be upfront. This isn't, getting this right or wrong isn't critical to understanding chemistry, but we'll just go with it for now. So, A, falling barometric pressure precedes the onset of bad weather. Is that a hypothesis, a law, or a theory? I don't have
Sounds
a strong
like a law.
I would tend to think it's a theory, but
if it's been measured and it's been shown to always be the case, then it's a law. So it highly depends.
Okay. Well, we don't need to argue that.
Yeah, yes. I think it's a law because of course they will say that the evolution law is a theory, and they will AGB, and they will say that and C is a hypothesis. So naturally, the only example of a law would be the first one.
Okay. And then so B, I would classify that as a hypothesis. I wouldn't even call it a workable theory, according to the way that they had presented it in chapter 1. I know some philosophers of science probably would classify things differently, so we're not going to belabor this.
I'm curious, James, you spoke of the law of evolution.
No, I said the evolution lie.
Oh, the evolution law. And what do you mean with that?
No, I said lie.
Oh, lie. Oh, evolution. Okay, yeah.
Okay. All right, so we'll just move on. Identify each of the following statements as being most similar to a hypothesis, a law, or a theory. Explain your reasoning. Again, guys, I'm not going to, we're not going to have to belabor this.
A is clearly a law. A is a law.
Yep, it's called the ideal gas law. It's similar to it. The ideal gas law is for ideal. Most gases are not ideal, but that's close enough. So I'd say A is a law. Matter consists of tiny particles that can combine in specific ratios to form substances with specific properties. I would say that's a law. At a higher temperature, solids such as salt or sugar will dissolve better in water.
Also a law?
Yeah. So let's see what the answer key said, all right? And sometimes I don't always agree with the answer key.
I think B is a theory, personally.
Yeah, it said B is a theory, C is a hypothesis.
Yeah.
A tentative explanation. Okay, so I'm not going to belabor this. I don't.
This is more philosophy.
Yeah. So that's for you, James, since you like philosophy. Okay.
James likes philosophy. We're going to have a good time together.
Okay, so let me see. Exercises. Go back. Identify which of the underlined items as part of either the macroscopic domain, the microscopic domain, or the symbolic domain of chemistry. For any in the symbolic domain, indicate whether they are symbols for a macroscopic or microscopic feature. Okay, the mass of a lead pipe is 14 pounds. I'd say that's macroscopic because you can observe it with an instrument. The mass of a certain chlorine atom is 35 AMU. That's atomic mass units, I think. I would say that's
symbolic, right?
I'd say that's microscopic.
Oh, okay. I thought that microscopic was. Oh wait, I'm confused. I was thinking about a microscope. I'm sorry. Indeed, that's microscopic.
Okay. Now we don't have the answer key for this because it's only the odd exercises we get answers for. A bottle with a label that reads AL contains aluminum metal.
That will be symbolic.
Yep, agreed. AL is the symbol for an aluminum atom, and I'll say that's symbolic.
Symbolic, yeah.
Okay. This one, the following does have an answer key. Identify which of the underlined items is part of either the macroscopic domain, the microscopic domain, or the symbolic domain of chemistry. For those in the symbolic domain, indicate whether they are symbols for a macroscopic or microscopic feature. We didn't do that in the last exercise. That's okay. We'll do it this time. A certain molecule contains one H atom and one Cl atom.
That's symbolic?
I would say so. And the molecule is in the microscopic domain. Copper wire has a density of about 8 grams per cubic centimeter.
Microscope? No, macroscopic.
Macroscopic, okay.
Because you can measure it.
Yes, directly.
It's sort of, yeah.
The bottle contains 15 grams of Ni powder. Ni, I believe, is nickel. I'd say this is the macroscopic domain, and Ni is the symbolic domain.
Yeah.
Okay, a sulfur molecule is composed of 8 sulfur atoms.
Microscopic?
Microscopic. So let's look at the answer key. 5. symbolic, microscopic, macroscopic, symbolic, macroscopic. I can't do both at the same time. I think we got it right, gentlemen. Okay. We have just 2 more exercises. According to one theory, the pressure of a gas increases as its volume decreases because the molecules in the gas have to move a shorter distance to hit the walls of the container. Does this theory follow a macroscopic or microscopic description of chemical behavior? Explain your answer.
Microscopic, because it describes the behavior of molecules and we cannot see them.
I would agree. Okay, and the last extra. I'm sorry.
I said me too. I also agree. It seems pretty obvious.
The amount of heat required to melt 2 pounds of ice is twice the amount of heat required to melt 1 pound of ice. Is this observation a macroscopic or microscopic description of chemical behavior? Explain your answer.
Macroscopic. It's.
I call it macroscopic.
Yeah, macroscopic. Yeah, it doesn't involve molecules or something. It's something that can be clearly seen by the human eye, it seems.
Okay, let's see the answer key. Macroscopic. The heat required is determined from macroscopic properties. So there we go. Well done, everybody. This is actually one thing about kind of doing chemistry in small parts, so to speak, that we don't try to swallow things too quickly. It's great when you can get everything right without having to try too hard. It just takes longer time. So now our topic today is phases. So that was chapter 1, and we scored 100 on our exercises. So now we will just go to the lecture section of 1.2, phases and classification of matter. We may not be, I try not to make these too long because we'll get worn out. And once it stops being fun, we don't learn as well. So we're going to cover phases and classification of matter. All right, so this is pretty straightforward. Again, anyone who wants this book, it's available for free online. The link is below. Matter is defined as anything that occupies space and has mass, and it is all around us. Solids and liquids are more obviously matter. We can see that they take up space, and their weight tells us that they have mass. Gases are also matter. If gases did not take up space, a balloon would not increase its volume when filled with gas. Solids, liquids, and gases are the 3 states of matter commonly found on Earth. A solid is rigid and possesses a definite shape. A liquid flows and takes the shape of its container, except that it forms a flat or slightly curved upper surface when acted upon by gravity. In zero gravity, liquid assumes a spherical shape. Both liquid and solid samples have volumes that are very nearly independent of pressure. Both liquid and solid samples have volumes that are very nearly independent of pressure. A gas takes both the shape and volume of its container. I mean, this should be fairly obvious, but once we start getting to the exercises, I found I had to actually think just a little bit. Okay, so these are the most common states and phases of matter. I just noticed something. See, the liquid can take the shape of the container, but it has fixed volume. The gas does not have fixed volume.
Yeah.
And there'll be a question on that. I mean, it should be obvious, but sometimes the obvious, you have to kind of just think a little extra. The 4th state of matter, plasma, occurs naturally in the interiors of stars. A plasma is a gaseous state of matter that contains appreciable numbers of electrically charged particles. The presence of these charged particles imparts unique properties to plasmas that justify their classification as a state of matter distinct from gases. In addition to stars, plasmas are found in some other high temperature environments, both natural and man-made, such as lightning strikes, certain television screens, and specialized analytic instruments used to detect trace amounts of metals. Oh, here's a
Sal, could you tell us a bit more about the physics behind it?
Sure. I'll try my best. Did we lose someone?
Yeah, Wouter, he had to go.
Oh, okay. The easiest state to understand is gas, where the molecules are just bouncing around because they have kinetic energy. It's just not quite billiard balls. With the billiard balls, you have, like, if you have a billiard table, there's friction, but with the gases, the speed of the molecules is not reduced when they bounce with each other. It's so they'll just be bouncing around. That's the easiest state. So a lot of the nice physics deals with gases. I'd say the next easiest is the solid state, and there are various things that will create the solid state, but one of them, like, say, salt, you get these things called ionic bonds that will, like when you have sodium and chlorine, the ionic bonds will cause the molecules to connect together, and so they don't move around, so it becomes a solid. The liquid state is kind of a nightmare to describe. We can describe the liquid state for certain things. Like, I believe with water, when it's in the liquid state, it has something called hydrogen bonds. So the solid state can have things like ionic bonds. I don't know what actually causes water to crystallize. So there are various mechanisms, chemical mechanisms, that create solid structure. So we'll be learning in chapter 2 or further the various kinds of bonds. Probably.
What about plasma?
Plasma is where the molecules are moving so fast, and when they're colliding with each other, it's at high temperature, and so they lose their electrons. So you have just a lot of these nuclei just floating around, and that means the matter is highly charged, and so even so sometimes there's a lot of plasma even in the cold of space, so to speak, because you have these charged ions just floating around, and then they can be subject to magnetic fields because they are electrically charged. So I'd say in order of difficulty of understanding, gases are the easiest. Crystal solids are probably the next easiest. Plasmas are probably a little bit easier to characterize, except you have to account for charges. They're somewhat like gases, but they're charged, and that adds kind of some complication. I'd say the worst is the liquid state in terms of the physics of it. So thanks. Those are great questions. So we'll just continue here. Some of these links, by the way, in the textbook don't work. I checked that. Some samples of matter appear to have properties of solids, liquids, and/or gases at the same time. This can occur when the sample is composed of many small pieces. For example, we can pour sand as if it were a liquid because it is composed of many small grains of solid sand. Matter can also have properties of more than one state when it is in a mixture, such as with clouds. Clouds appear to be somewhat like gases, but they're actually mixtures of air, gas, and tiny particles of water, liquid and or solid. The mass of an object is a measure of the amount of matter in it. One way to measure an object's mass is to measure the force it takes to accelerate the object. It takes much more force to accelerate a car than a bicycle because the car has much more mass. A more common way to determine the mass of an object is to use a balance to compare its mass with a standard mass. So if you have a balance, you have gravity to help you, but in the weightlessness of space, you would need other devices to measure mass. Although weight is related to mass, it is not the same thing. Weight refers to the force that gravity exerts on an object. This force is directly proportional to the mass of the object. The weight of an object changes as the force of gravity changes, but its mass does not. An astronaut's mass does not change just because she goes to the moon, but her weight on the moon is only 1/6 her earthbound weight because the moon's gravity is only 1/6 that of Earth's. She may feel weightless during her trip when she experiences negligible external forces, gravitational or any other, although she is, of course, never massless. Here's a law of nature. The law of conservation of matter. The law of conservation of matter summarizes many scientific observations about matter. It states that there is no detectable change in the total quantity of matter present when matter converts from one type to another, a chemical change, or changes among solid, liquid, or gaseous states, a physical change. Brewing beer and the operation of batteries provide examples of the conservation of matter. During the brewing of beer, the ingredients, water, yeast, grains, malt, hops, and sugar are converted into beer, water, alcohol, carbonation, and flavoring substances with no actual loss of substance. This is most clearly seen during the bottling process when the glucose turns into ethanol and carbon dioxide, and the total mass of the substances does not change. This can also be seen in a lead acid car battery. The original substance says lead oxide, and sulfuric acid, which are capable of producing electricity, are changed into other substances, lead sulfate and water, that do not produce electricity, with no change in the actual amount of matter. That's actually, I would say that's probably one of the most important chemical laws. It's so obvious now, but I don't think it was very clear when we were first, when scientists were first looking into this, or for that matter, the alchemists. Any comments?
Not specifically.
Okay. And so we're also starting to get a taste of some of the chemical notations. So I think Pb is lead. You can see that here. PbO2 is lead oxide. H2SO4 is sulfuric acid. I think that's lead sulfate, PbSO4, and then H2O is water. So now we got to do actually some real chemistry for a change. Although this conservation law holds true for all conversions of matter, convincing examples are few and far between because outside of the control conditions in a laboratory, we seldom collect all of the material that is produced during a particular conversion. For example, when you eat, digest, or assimilate food, all the matter in the original food is preserved, but because some of the matter is incorporated into your body and much is excreted as various types of waste, it is challenging to verify by experiment. So, classifying matter. Matter is classified into several categories. This is actually going to be, this is not 100% critical to chemistry, but this is kind of one of the more tough aspects of this because it's really persnickety. This would probably be something a philosopher would enjoy. Okay. Matter can be classified into several categories. Two broad categories are mixtures and pure substances. A pure substance has a constant composition. All specimens of a pure substance have exactly the same makeup and properties. Any sample of sucrose, table sugar, consists of 42.1% carbon, 6.5% hydrogen, and 51.4% oxygen by mass. Any sample of sucrose also has the same physical properties, such as melting point, color, sweetness, regardless of the source from which it is isolated. Pure substances may be divided into two classes: elements and compounds. Pure substances that cannot be broken down into simpler substances by chemical changes are called elements. Iron, silver, gold, aluminum, sulfur, oxygen, and copper are familiar examples of the more than 100 known elements, of which about 90 occur naturally on Earth, and 24 or so have been created in laboratories. So let me just go on this a little more, and then we'll take a pause. Pure substances that can be broken down by chemical changes are called compounds. This breakdown may produce either elements or other compounds, or both. Mercury oxide, an orange crystalline solid, can be broken down by heat into the elements mercury and oxygen. When heated, in the absence of air, compound sucrose is broken down into the element carbon and the compound water. The initial stage of this process, when the sugar is turning brown, is known as caramelization. This is what imparts the characteristic sweet and nutty flavor to caramel apples, caramelized onions, and caramel. Silver chloride is a white solid that can be broken down into its elements, silver and chlorine, by absorption of light. This property is the basis for the use of this compound in photographic films and photochromic eyeglasses, those with lenses that darken when exposed to light. Wow. I didn't realize that. So some of these glasses that just change color depending on how much light, there's actually a chemical, seems to be a chemical change. I didn't notice that the first time I was reading it. It didn't really register. Any comments?
I don't really have a comment, actually.
Okay. So let me just look at this diagram. It says here, the compound mercury 2 oxide, when heated, decomposes into silvery droplets of liquid mercury and invisible oxygen gas. Okay, I'm just gonna skip that. The properties of combined elements are different from those in the free or uncombined state. For example, when crystalline sugar is a compound resulting from the chemical combination of the element carbon, which is a black solid in one of its uncombined forms, and the two elements hydrogen and oxygen, which are colorless gases when uncombined. Free sodium, an element that is is a soft, shiny metallic solid, and free chlorine, an element that is a yellow-green gas combined to form sodium chloride, table salt. A compound that is white is a white crystalline solid. Okay. Mixture is composed of two or more types of matter that can be present in varying amounts and can be separated by physical changes, such as evaporation. You will learn more about this later. A mixture with a composition that varies from point to point is called a heterogeneous mixture. Italian dressing is an example of a heterogeneous mixture. Its composition can vary because it may be prepared from varying amounts of oil, vinegar, and herbs. It is not the same from point to point throughout the mixture. One drop may be mostly vinegar, whereas a different drop may be mostly oil or herbs, because the oil and vinegar separate and the herbs settle. Other examples of heterogeneous mixtures are chocolate chip cookies. We can see the separate bits of chocolate, nuts, and cookie dough. And granite, we can see the quartz, mica, feldspar, and more. Let me just back up a little bit. I need to see. I don't know if they've covered compounds. I'm just going to move on. A homogeneous mixture, also called a solution, exhibits a uniform composition and appears visually the same throughout. An example of a solution is a sports drink consisting of water, sugar, coloring, flavoring, and electrolytes mixed together uniformly. Each drop of a sports drink tastes the same because each drop contains the same amount of water, sugar, and other components. Note that the composition of a sports drink can vary. It could be made with somewhat more or less sugar, flavoring, or other components. and still be a sports drink. Other examples of homogeneous mixtures include air, maple syrup, gasoline, and a solution of salt in water. Okay. So figure 1.10. Oil and vinegar salad dressing is a heterogeneous mixture because its composition is not uniform throughout. B, a commercial sports drink is a homogeneous mixture because the composition is uniform throughout. Okay. Although there are just over 100 elements, tens of millions of chemical compounds result from different combinations of these elements. Each compound has a specific composition and possesses definite chemical and physical properties that distinguish it from other compounds. And of course, there are innumerable ways to combine elements and compounds to form different mixtures. A summary of how to distinguish between the various classifications of matter is shown in figure 1.11, and here it is. So for the philosophers out there, this is kind of a, I think this is kind of interesting how they decided to classify things like this. It's amazing. It's actually, when we go through some of the exercises, we'll be going through these decision tables. I mean, just from my standpoint, I didn't realize, I mean, I sort of knew it, but gasoline is actually a mixture of substances. It's not just a single chemical. All right. 11 elements make up about 99% of the Earth's crust and atmosphere. Oxygen constitutes nearly 1/2, and silicon about 1/4 of the total of these elements. A majority of the elements on Earth are found in chemical combinations with other elements. About 1/4 of these elements are also found in the free state. Okay, so I think silicon dioxide is sand. So I think that's why a lot of the Earth's crust is made of oxygen. So this is just, I'm going to just breeze through this table unless anyone really wants to, if you want to comment as I'm going through this, feel free. So oxygen makes a huge percent of the mass. Silicon, aluminum, iron, calcium, sodium, potassium. Carbon only makes a very small amount of the Earth's surface. So all living things need carbon. By the way,
isn't it interesting that people who believe in evolution think that only 0.08% of matter was suddenly transformed into life?
Yeah, exactly.
Why not why not hydrogen or oxygen or something like that?
Well, carbon has very special properties.
Yeah, I know.
Oh, wow, great. So,
but it was more of a rhetorical question with regards to the evolution people.
Life is constructed with carbon, which makes it very. We can do some very interesting statistics to show that this is a very improbable structure. By the way, just let me point out something. I believe 90 or 99% of a big proportion of our body is made of 6 elements here: oxygen, hydrogen, carbon, phosphorus, and sulfur. Oh, and nitrogen. Is nitrogen listed here? Let's see. Nitrogen, yes. So life is mostly made of carbon, hydrogen, oxygen, nitrogen, phosphorus, and sulfur. I got that from the cell biology textbooks. Okay, so we'll just keep moving. Atoms and molecules. An atom is the smallest particle of an element that has the properties of that element and can enter into a chemical combination. Consider the element gold, for example. Imagine cutting a gold nugget in half, then cutting one of the halves in half and repeating the process until a piece of gold remained that was so small that it could not be cut in half, regardless of how tiny your knife may be. This minimally sized piece of gold is an atom, from the Greek atomos, meaning indivisible. This atom would no longer be gold if it were divided any further. That's a gold nugget, and scanning tunneling microscope can generate views of the surface of solids, such as this image of a gold crystal. I didn't know gold could crystallize. Each sphere represents one gold atom. Wow. Isn't that awesome? We actually could see the atom, or, kind of a depiction of it. Pretty high fidelity depiction. The first suggestion that matter is composed of atoms is attributed to the Greek philosophers Leucippus and Democritus, who developed their ideas in the 5th century BCE. However, it was not until the early Yes.
So you have to say before Christ.
Oh, thank you. Before Christ. Yes, thank you. Who developed their ideas in the 5th century before Christ. Praise the Lord. Thank you. No, thank you. This is good. However, it was not until the early 19th century that John Dalton, who I believe was a Christian, a British school teacher with a keen interest in science, supported this hypothesis with quantitative measurements. Since that time, repeated experiments have confirmed many aspects of this hypothesis, and it has become one of the central theories of chemistry. Other aspects of Dalton's atomic theory are still used, but with minor revisions. Details of Dalton's theory are provided in the chapter on atoms and molecules. Speaking of which, details of Dalton's theory are provided in the chapter on atoms and molecules. I'm sorry. Let me double check. John Dalton.
He was a Quaker, by the way.
Hey, I would consider him in my book, I would consider him a Christian.
Yeah, in the broad sense of the word, yeah, Quakers can definitely be called that.
So, that's just beautiful. See, this is proof that people that believe in a creator can be great scientists, because this is he's a great scientist because this is a central discovery in chemistry.
It should seem pretty obvious. Alexis Carrel, Leonardo da Vinci, Copernicus, they were all Christians.
Yes. Praise God for them.
Isn't the inventor of the MRI scan affiliated with Answers in Genesis?
He is a creationist, Raymond Damadian. I don't know his affiliation, but he's a creationist. Yeah. I believe he's even a young Earth creationist. So it's just great to know that when I was going through secular school and I'd read all these names, I'd find out if these were Christians. I couldn't believe how many of the founders of science were Christians or professed Christ or believed in the Bible. I said, that's very encouraging, because they the secular world today tries to insist that one can't be a scientist and also a Christian. So,
which is completely ludicrous.
Yeah.
It's just a Marxist perspective on science, really, nothing else.
Amen. Amen.
The complex thesis is just so ahistorical. It makes me mad.
Me too. So we'll move forward here. An atom is so small that its size is difficult to imagine. One of the smallest things we can see with our unaided eye is a single thread of a spider web. These strands are about 1/10,000th of a centimeter in diameter. Although the cross-section of one strand is almost impossible to see without a microscope. It is huge on an atomic scale. A single carbon atom on the web has a diameter of 0.000000015 centimeter, and it would take about 7,000 carbon atoms to span the diameter of the strand. To put this in perspective, if a carbon atom were the size of a dime, the cross-section of one strand would be larger than a football field, which would require about 150 million carbon atom dimes, quote unquote, to cover it. Figure 113 shows increasingly close microscopic and atomic level views of ordinary cotton. Wow. So let's see. D, atomic level models of the fiber. An atom is so light that its mass is almost difficult to imagine. A billion lead atoms weigh about 3 times 10 to the minus 13 grams, a mass that is far too light to be weighed on even the world's most sensitive balances. It would require over 300, followed by all these zeros, lead atoms. That's 300 trillion, or 3 times 10 to the 14th, to be weighed. And they would weigh only 0.0 something 1 grams. It is rare to find collections of individual atoms. Only a few elements, such as the gases helium, neon, and argon, consist of a collection of individual atoms that move about independently of one another. Other elements, such as the gases hydrogen, nitrogen, oxygen, and chlorine, are composed of units that consist of pairs of atoms. One form of the element phosphorus consists of units composed of 4 phosphorus atoms. The element sulfur exists in various forms, one of which consists of units composed of 8 sulfur atoms. These units are called molecules. A molecule consists of 2 or more atoms joined by strong forces called chemical bonds. The atoms in a molecule move around as a unit, much like the cans of soda in a 6-pack, or a bunch of keys joined together on a single key ring. A molecule may consist of 2 or more identical atoms, as in the molecules found in the elements hydrogen, oxygen, and sulfur, or it may consist of 2 or more different atoms, as in the molecules found in water. Each water molecule is a unit that contains 2 hydrogen atoms and 1 oxygen atom. Each glucose molecule is a unit that consists of 6 carbon atoms, 12 hydrogen atoms, and 6 oxygen atoms. Like atoms, molecules are incredibly small and light. If an ordinary glass of water were enlarged to the size of the Earth, the water molecules inside it would be about the size of golf balls. Now, this passage here is actually kind of important for the exercises because it defines what a molecule is. Molecules consist of 2 or more atoms joined by strong forces. So let me point something out. That's the definition of a molecule in this textbook. It has to be 2 or more atoms. I seem to recall that other textbooks might classify even a single atom as a molecule. Don't hold me to that. But as far as this textbook goes, it has to be 2 or more atoms. So any comments? We're getting into some heavy chemistry now because they're reading off a lot of chemical terms now, which is good. We're finally starting to actually do chemistry. Any comments, or just want to take a break? Let me just take a quick look, see how much more we have to go. We have just a little bit more to go, and then we're done.
How long will it take to finish it up, you think?
Maybe in about 10 minutes, even less. Because you have to go? We can just...
No. But Montesquieu was interested in your work.
Indeed, I am very much.
Oh, okay. We can talk about that. How about we finish the lecture and then we can just talk. Would you like that?
Yeah,
would that work?
Yeah.
Okay. So, this is kind of this graph here. Let me bring it up. This is now we're starting to touch a little bit on chemistry. Unfortunately, the next few sections in future lectures will be anything but chemistry. It'll be just a lot of basic stuff on measurements and conversions. So at least we got a taste of real chemistry here. The next few lectures after this will not actually be specifically on chemistry. They'll actually be almost a little bit more like physics lectures. So James, since you're interested in physics, the next few will be lectures that would be helpful for studying physics and chemistry. So physics and decomposition of water. So this is just an example. Water consists of the elements hydrogen and oxygen combined in a 2-to-1 ratio. Water can be broken down into hydrogen and oxygen gases by the addition of energy. One way to do that is with a battery or power supply. Oh boy, what happened? I lost my... Let me see if I could redo this. For some reason my browser died. So this is pretty easy. Just throw a lot of electricity on water and you can actually make hydrogen. I would suspect this is how they make liquid hydrogen to power some of the rocket ships. Okay, so we might as well do a little chemistry here. The decomposition of water is shown at the macroscopic, microscopic, and symbolic levels. So you can actually see that here on the left is the macroscopic description, and the microscopic is here, which is just has to be imagined, and then the symbols are here. At the macroscopic level, the liquid separates into the gases hydrogen on the left and oxygen on the right. Symbolically, this change is represented by showing how liquid H2O separates into H2 and O2 gases. The breakdown of water involves rearrangements of atoms in water molecules into different molecules, each composed of 2 hydrogen atoms and 2 oxygen atoms, respectively. 2 water molecules from 1 oxygen molecule and 2 hydrogen molecules 2 water molecules form 1 oxygen molecule and 2 hydrogen molecules. The representation for what occurs is 2H2O equals, so that's 2 molecules of water liquid, make 2 molecules of hydrogen gas and 1 molecule of oxygen gas. This will be explored in later chapters. The 2 gases produced have distinctly different properties. Oxygen is not flammable, but is required for combustion of a fuel, and hydrogen is highly flammable and a potent energy source. How might this knowledge be applied to our world? One application involves research into more fuel-efficient transportation. Fuel-celled vehicles run on hydrogen instead of gasoline. They are more efficient than vehicles with internal combustion engines, are non-polluting, and reduce greenhouse gas emissions, making us less dependent on fossil fuels. I think that's not really being very truthful. FCVs are not yet economically viable, however, and current hydrogen production depends on natural gas. So that means you need a fossil fuel to make a hydrogen-powered car. So you still have to burn fossil fuels, quote unquote fossil fuels. If we can develop a process to economically decompose water or produce hydrogen in another environmentally sound way, FCVs might be the way of the future. All right. So there you go. There's a little bit of an agenda there. Doesn't like fossil fuels. A fuel cell generates electrical energy from hydrogen and oxygen via an electromechanical process and produces only water as the waste product. Okay, we could skip this. This cell phone stuff was not very fun when I read it the last time. So that's it for our lecture. We'll continue talking since Montesquieu wanted to talk. So everyone's welcome to hang out for this talk, but that concludes section 1.2 on the phases of matter, and we may cover the exercises in the next lecture just as a review. So,
it was fascinating.
Oh, thank you. So, what do you know of my work, Montesquieu? What did you learn about it through James, or have you seen my website?
But I've also read about it, and obviously, probably the elephant in the room is your work with John Sanford, which is a good thing.
Oh yes, thank you. Dr. Sanford worked definitely in the area of genetics, and when I got hired 7 years ago, it was a variety of projects that we worked on. It was no one thing. My first project was looking at radio waves in whether DNA could generate radio waves. It turns out DNA has a lot of interesting applications in the cell beyond coding for proteins. It creates vibrations that shepherd molecules around the cell nucleus. That's very interesting. I was supposed to look at patterns within DNA, multiple codes, and I have found in the literature. So I had to survey the literature on the multiple codes in DNA and some of the uses of DNA, particularly the non-coding DNA. So because the evolutionists kept saying that all this is junk, it's an evolutionary accident, it has no function. And so I was monitoring the developments that would suggest that the DNA has a lot of function in the non-coding areas. And so I had attended conferences and I read papers, and then I would report to Dr. Sanford. One of the things that I found out is about 90% of our inherited diseases or diseases that are related to DNA are in the non-coding areas. And that's why there is interest in non-coding DNA. So this is very ironic. The evolutionary biologists are insistent, many of them, that junk DNA has to be junk. Large amounts of non-coding DNA have to be junk. Otherwise, evolutionary theory is false.
So then it would appear to be false, right? Because junk DNA seems to...
As far as human evolution. But the thing that was funny is that it's the medical researchers that said, well, we're here, we're studying our disease. Like, so I was at these conferences and I go to the conference and they said, well, okay, this form of diabetes seems to be associated with this region, the non-coding region of this DNA. And then so each of these researchers had their particular specialty of a disease, and all of them are saying, okay, we found it to be associated with this section of non-coding DNA, and you get the same story. And so the sentiment was that if you just are willing to just kind of extrapolate this a little bit, it would suggest that a lot of the non-coding DNA is very important. And so this is how all this began. And maybe $1 billion of money was thrown at all these research projects, just looking at the non-coding DNA for medical purposes. This had nothing to do initially with the creation evolution controversy. It became part of the creation evolution controversy when the evolutionary biologists like Dan Graur weighed in, because it made them look bad. Because they're saying this is a great prediction of evolutionary biology. Look at this is all junk. And the experimental evidence did not agree. So the observation and experiment did not agree with evolutionary predictions. So this was a big embarrassment to them. They were furious. They were mad. They were calling the researchers at the NIH, crooks, ignoramuses. I mean, just really nasty things, equivalent to terrorists.
So personal attacks because your research was threatening to their ideology, basically?
Yes. So this was fun to weigh in on it because it was just, I just like, these guys these guys aren't even creationists. You just don't like what they're discovering. Go on.
Weren't you threatened at your university for your beliefs or something?
Johns Hopkins University. Yeah.
Yeah. They tried to let you resign or something, right?
What happened was people saw me on the internet. They tried to contact professors. They contacted professors at Johns Hopkins. And I was in a physics program, not a biology program. I was in a physics program, applied physics, which is engineering physics. It has very passing immediate relevance to creationism, except maybe the idea of distant starlight. And, that's probably the only thing, one of the only big things that it would conflict with. But they were so mad, they were contacting professors there. And one of the professors, they contacted a professor at a different physics department than the physics department I was studying under. And he said, he's not going to get involved in that, said it's outside my department. So good on him. Even though he's not very friendly toward me personally, he had enough integrity to say, I'm not going to dirty my hands in this. And so the other thing is I was a paying student. So why would the university gets paid to have a student go and take classes. So why would they want to expel me? But it was still kind of nasty behavior. Now, unfortunately, other people are not so lucky. So depending on the institution and who the people are in that institution, the treatment could be very bad. So I've heard stories from being treated very good to stories of being very bad. So there are young earth creationists that get their PhDs. I know some of them personally. They go to very fine schools. And one reason they're able to get through is they're really brilliant students. It's like, well, such and such is a really good organic chemist. Why are you gonna throw them out because they're a Christian? Or they're a very good computational scientist.
Yes, we have that here in the Netherlands as well, that if you're intelligent enough, you can break through the censorship web, basically. You can break through the indoctrination system in universities. You can still get your PhD.
You can. It's no guarantee. Nothing's guaranteed. But I'm finding that Christians and those who are homeschooled end up being very good students. And I think any teacher that is passionate about really teaching science rather than having an agenda would welcome having dedicated students. And so why would they feel that way? Now, there is someone on my channel who's a professor of evolutionary biology. He is definitely on the left side of the political spectrum. He and I get along, and I asked him, have you had any creationist students? He said, yes. And he explained that he didn't give them any trouble, and I accept that. He said, so it just depends. Some professors, they'll take it really personally and feel it's their mission to destroy a student that's a Christian. And others are like, well, we disagree, they're creationists, but we will respect them. So, I would say that, let me just say this. John Sanford sent me to my biology training. So I had my degree in physics, a Master of Science in Applied Physics. I started working for Dr. Sanford. He said, I'm going to send you to the National Institutes of Health. They have a graduate school there. And so I basically learned about God's creation from evolutionists. And he knew that was what was going to happen. So this is a good thing to talk about, is that if someone really loves the Lord and wants to study his creation, he's going to have to probably matriculate through a non-Christian college. There are Christian colleges in the United States, but there's certain specialties that maybe the best path is to go to a secular school. And Dr. Sanford, who's a creationist, he insisted I go to a secular school.
It's pretty sad, though, because most of the Ivy League universities were founded as specific Christian universities.
Yes.
For example, Harvard was a very puritanical university at first.
And let's not forget that universities...
And Notre Dame was very Catholic. And so you have all these institutions that were very conservative and religious. And you had a couple of other ones. I think Chicago University was Baptist.
I didn't know that.
So you had all these universities, and now they are all atheist, basically.
And, yeah, that's sad. It happens.
Let's not forget that the modern university was a medieval invention from the 11th century. It's a Christian European introduction. Right. It's interesting. I think that the first documents guaranteeing academic freedom in Europe were in fact specifically approved of by the medieval papacy. So that's something that a lot of atheists wouldn't want you to mention.
Yes, thank you for reminding me of that. And then, it's kind of unfortunate. I actually think that just because and again, because this is my experience having worked for Dr. Sanford, is that we tend to think that, if we want someone to grow in the faith, send them only to Christian schools. I wouldn't say that is universally true, because my faith grew going to a secular school. Because as I studied the biology, I began to see, I say, only God could make this. So there I was, I'd be sitting in class and they'd be talking about cellular biology. And I could tell you, every lecture, I walked out of there feeling closer to God. I said, there is a God. Amen. Praise the Lord. I couldn't say that in class. I didn't want to disrupt the classroom, but it was hard not to I had to shut my mouth, and because so many times they'd show a system and I'd say, praise the Lord for his marvelous work.
Really fascinating that it was your experience. I had something similar already in high school, but I had it primarily when I read history. Like studying history, I came close and close to the Christian faith because I wasn't raised religiously. I grew up in a secular household in one of the most atheist countries in the world.
Wow.
But studying history just made me close and closer to Christianity. And it was kind of double. Like, what it really started with was that I just came to identify as a cultural Christian, that I came to support Christian morality and the influence of Christianity in society, even when I was still leaning atheist or at least agnostic when it came to the existence of God. It was like, even if I end up concluding that God probably doesn't exist, I still support Christianity, but then obviously Orthodox Christianity. And I mean Orthodox in the sense of, fundamentalist, conservative. That was already what I thought when I was like 13 years old. But the question of whether God existed also fascinated me. So I kept thinking about it, and I kept looking into that whole question. And I also have to admit I did have the fascination with Eastern religions, but not the stuff with the Dalai Lama or something. No, I had a thing for Confucianism and all that. But even then, I still just, conservative Christianity to me was something very inspiring, because I was already against abortion. Just for purely secular natural law reasons, I was against abortion. And I thought the fact that Christians fought abortion showed that Christians were good influences on society. And I also thought that many of the worst dictators had been anti-theistic, secularists like Mao and Hitler and Stalin. So those were the kind of things that brought me closer and closer to the Christian faith.
Oh, praise God. Are you familiar with the works of Tom Holland?
Yes, somewhat, yeah.
Oh, yeah. I only learned about him, and he considers himself a cultural Christian. And he echoes a lot of your sentiments, because he began to realize so many of his values that he thought were secular. And he realized as he studied history that they actually had Christian roots. So even the Enlightenment, he realized the Enlightenment values were ultimately Christian, even though the Enlightenment tried to reject Christianity. They couldn't run away from the Christian roots completely.
I definitely agree that the moderate Enlightenment as such is represented by people like Montesquieu and Also later on, people like Edmund Burke, ironically, was definitely very Christian in origin. It's mainly the radical Enlightenment that can be viewed as anti-Christian, like the ideas of Rousseau and Marquis de Sade. They were truly anti-Christian thinkers, like their full-blown naturalism. And I will say, full egalitarianism is inherently anti-Christian, because a lot of the things that Christ says don't make any sense. Like, that the first will be the last will be the first. Doesn't make any sense if there are no first and there are no last. That's why.
Wow. I never thought of that. Wow.
It's very interesting. Christ's teachings make it very clear that there is such a thing as basically a natural hierarchy, that natural inequality exists and is in fact natural, not a social construct, and that this isn't in and of itself wrong, but that the supernatural hierarchy will often be an inverse of this, because of the fact that having a high position in the natural hierarchy often makes it more difficult to be saved. Like being rich, being powerful, and having a lot of glory and influence doesn't mean you're damned by definition, but it makes salvation a lot more difficult, while being a slave or being poor makes humility and complete openness to God more easy.
Yes, absolutely. And even for very simple things, when someone is poor and doesn't have a lot of options, the idea of God and eternal life seems very, very attractive.
Yes, that's
because you have nothing to lose by following God at that point, because you have nothing. It's when you have so much that you might have to give up. It can be a big stumbling block. Yeah.
I definitely agree on that. I am happy about the fact some people have in fact succeeded in doing so, that you have had rich people who converted and gave away almost all of their wealth. That's truly inspiring.
Well, I mean, even on a more basic level, when you feel like all your needs are met, you just feel like sometimes you have no need of God. But let's say sickness afflicts you or problems come your way, then you begin to say, I can't fix this on my own. I need help from a higher power. And poor people are always very often in that state where they're needing to call out. And so John Sanford this is public knowledge, he was a very successful scientist. But, this is public knowledge. He said he and his wife were trying to improve their marriage. And the wife suggested, let's start going back to church. And that's because all of his science and knowledge could not fix that.
It's truly beautiful to hear that, because I actually convinced my father to return to the Catholic Church that he was raised in. And I convinced my mother to join and get baptized as well. And their marriage and our entire family got a lot tighter and like a lot happier, like when that happens. At this point, that's like nearly 10 years ago, but it was truly wonderful to be able to basically help to convert both my parents and see it change them for the better.
Yes. So basically, when one is, you see this pattern in the Bible when some, like the kings of Judah got prosperous, they began to forget the Lord.
Like Solomon.
Yeah. So, Jesus said the cares and the pleasures of this world can prevent growth. So there is definitely a point where even the cares and worries of this world can
even King David became a sinner.
Oh yeah. Oh yeah.
It's interesting. David wasn't as bad as Solomon, but indeed David sinned as well. I have to admit, I've sometimes wondered whether Solomon was even saved. I did wonder that in the past sometimes.
Yeah, I still do. And I don't, that's, the Lord never told us one way or the other. I think the Lord is saying that, the humans are the messengers of his word, because many of the things Solomon wrote are part of our Bible, and it's sacred text coming from God himself. So I've thought about that too. Before we go any further, just some feedback. Was this about the right length of time to spend on a chemistry lecture?
I would say so.
It wasn't overly long or ponderous like they can sometimes be, which was very good, but it didn't feel rushed either.
Okay. So we'll just take it in small pieces. There'll be some sections that will really be very laborious. I've gone through them and I'm just like, oh my goodness, when is this going to end? I mean, so the first, these weren't too bad. It's going to get a little more challenging, and we'll have to take a little bit more breaks and just kind of relax our minds, because it is not, it's not pleasant work. This is, like I said yesterday, this is somewhat like bearing your cross. Unless you're like my cousin Libby, she just loved homework. Oh my goodness, she loved homework.
I
and
love
lectures.
homework as well, but I have to admit, I prefer it for certain subjects over others. Like, if you gave me homework regarding constitutionalism, I can like listen to that for 5 hours straight.
Wow. That's wonderful. So the second thing is, since you're new, Montesquieu, how can I be of service to you? Is this lecture helpful for you, or did you have something else in mind?
No, it was definitely helpful for me. And no, I expected a lecture about chemistry, and it was extremely good. It's actually understanding, well, no, not understanding, just having it mapped out so coherently. You know, the difference between like mixed substances and the pure ones and all that. Like, this is stuff that you get in high school, but you know, somehow it all gets kind of muddled. It became way more coherent this way, and that was good.
Well, I'm finding even the high school level stuff, I need to review it because it's very easy to forget the basics. So if you want to, James, would you like to continue with these chemistry series? You're getting your money's worth. You could buy a car in the United States for the cost of what you'll be getting through this series, but it will be, it will be about the equivalent. I'm trying to aim for what one would get through a year of college. So if we could do it day by day and just,
Sounds wonderful to me.
Okay. So I sometimes have meetings. I actually have to meet with a chemist sometime, a project I'm working on. So Montesquieu asked about some of my other work. I do work on a particular enzyme called topoisomerase 2 alpha. And I work with a professor of biochemistry, Joe DeWeese, on that. And so he likes to have his meetings in the afternoon. But if I don't have and then one of Dr. Sanford's colleagues I work with, and we meet on Mondays at 2 p.m. So as far as timing, 2 p.m. usually will work for me, except on Mondays. But even then, depending on your time zone, I can do a little later than 2 p.m.
Totally fine with me.
Okay. Would you, James, can you pass on my email to Montesquieu?
Yeah, I already did. I passed on the email of your ER Academy account, or do I have to pass on your regular email?
Either will work. And let me just check to see I got it.
Montesquieu, did you send Sal an email already?
I don't see it here yet.
No, I haven't sent an email yet. I didn't know I was supposed to do that now. I can do it now if you'd like.
Anytime, but that way I can send you the links to the lecture. I have to generate a new link in StreamYard each time we do a lecture.
No, exactly. So I'm going to try to to send you an email now. So I hope it works. I'm curious, by the way, are you dedicated entirely to chemistry, or are you also interested in other subjects?
Oh, I'm interested in other subjects. I'm just doing chemistry lectures here, partly to re-educate me. There are topics in cellular biology. I really like cellular biology. My background was in the aerospace and defense industry. My 5 science degrees. My first was in computer science. The second was in electrical engineering with a minor in music. The third was in mathematics with a minor in physics. Then I got a master's in applied physics, and then a master's equivalent, unaccredited, in biology. So those are my specialty areas. So as far as creationism, the easiest stuff right now is the origin of life. The next hardest is evolutionary theory, because there's some, abiogenesis is separate from evolutionary theory in that in abiogenesis you don't have genomes, whereas in evolutionary theory you have genomes. So there is a difference in kind of the phase in terms of the ideas.
What always
Abiogenesis,
annoys me most about the evolution theory is their tendency to take proof for microevolution as proof for macroevolution. There are few
yes,
things as annoying as that.
yes, and my specialty was actually showing where this really fails at the protein level. Protein at the level of protein architecture, it really fails as an argument, and I can demonstrate that very clearly. In fact, it was so clear that someone I debated, Professor Dr. Dan Stern Cardinal, we had debated each other, but we're on friendly terms. He came to my channel and I said, Dan, do you think all major protein families descended from a single protein? He said, no. And just about everyone else is saying that. I said, so there's no universal common ancestry of proteins. And they said, yeah, there's none. They believe in organismal common ancestry, but even that, now the evolutionary biologists are starting to bend on that. They say the last universal common ancestor was a population of organisms, which means there was no universal common ancestor. That's just the way, that's just a new double speak.
By the way, I have to check. So do you also have a YouTube channel?
I have the other YouTube channel. This is one YouTube channel, Evidence and Reasons Academy. But if you go to the about page of this channel, you should see the Evidence and Reasons for the Christian Faith video channel. So there we explore kind of in a somewhat less academic, but it's still very technical, evidences of the Christian faith. So you'll see me explore creationism, and I'll talk about protein macroevolution. I'll talk about eukaryotic evolution. I'll talk about abiogenesis. I covered a little bit, maybe just 2 shows on the Big Bang, because that aspect of creationism is very difficult. I would like to do stuff on radiometric dating. I just haven't gotten around to it. And then we talk about archaeology. Someone got saved because our pastor was talking about Hezekiah's tunnels and the Taylor Prism, and he was in a really bad place, and it's just amazing that just to talk about archaeology turned his heart toward God. Amazing, because archaeology is showing that the intelligent designer is the Christian God, because it's a record of that Israel was real and many of the events were real, all of the events, I'm sorry. And then same for the New Testament, very compelling. The other pillar of Christian evidence is personal testimony, the miracles throughout history, and then even the miracles in people's lives today for their changed lives. And like you gave the example of your parents going back to Catholic Church, God started to do things in their life. And I see that there's a whole spectrum of, I'm seeing that happen in people's lives. I've never met an atheist that once he became an atheist, he started to, find so much more meaning and hope in life.
No, indeed, atheism seems to inherently tend towards nihilism.
Yes,
or
absolutely.
hedonism.
Yes, definitely that as well. Atheism doesn't have to lead to hedonism. You can ironically adhere to kind of a form of principalic and ascetic atheism, but then you aren't a true skeptic. You aren't a true materialist. You can basically be an idealistic atheist, but at that point, the atheism has already become arbitrary. You can be an atheist who chooses to believe in abstract notions like love, friendship, and morality, but all of those are as much abstract concepts that aren't materially demonstrable as faith in God.
Yes. So we do a little bit of examining, because of the Christian testimony of individual conversions, it leads to, something I've said is there are no answers in atheism. So there's two separate YouTube channels. This one that does really academic stuff like what we just did today. And then the other one where we have kind of isolated lectures and talks, and then a few shows. So some of our presuppositional apologetics on that channel is very, very simple. It's like there's no answers in atheism. It's very simple at that point. It's like, okay, it's kind of a dead end. So I explored a little bit of Pascal's wager, and then that led to some political things. Of late, there's been some problems in my local church that I'm a member of, and I gave a video that pointed out some things that one of my pastors there said. He said, it's difficult for me not to torch all white people, especially white evangelicals and Christians. He's an African American. And when I broke that video, it went viral. It's gotten 70,000 views, maybe 6,000 on my channel, but then the video got replayed elsewhere, and it's now about 70,000 views. And so my channel actually exploded because of that one video, which is kind of, it's like that had nothing to do with what I traditionally talk about. So I've actually been doing a little bit more on that, because that's kind of like a cultural apologetic, because apologetics is defense of the faith, and this whole social justice thing that's invading the church is a false gospel. And so just like apologists have to defend against false gospels, I stood up for that.
That's very good. That's excellent.
Oh, thank you. So that's just a brief overview of the channel. So I invite you to look at the channel. It's very, we do a few Bible studies. So for me, apologetics is using things outside the Bible to inspire faith in the Bible. And that's why a lot of churches feel a little uncomfortable with that, because they're like, well, why are you studying chemistry to help you in your Christian faith? Or why are you studying cell biology to help you in your Christian faith? But you see, that's where we got like things like genetic entropy that can, lend credibility to the Bible. And a lot of churches haven't caught on that this might be the way to actually defend the faith, is to appeal to things outside the Bible.
Yes, that's a sad tendency I've unfortunately seen within many fundamentalist Protestant currents, that they seem to have a tendency similar to fundamentalist Islam, where their sola scriptura tendencies go so far that even matters that aren't directly related to the faith, they still think they must all be analyzed entirely according to the Bible. Like there is no knowledge outside of the Bible. The Bible is not only a source of revelation. No, it is like the guide for science and for politics in everything. Tendencies that appear fundamentalist in a narrow fashion instead of a merely orthodox fashion. That's a tendency I've seen a lot within certain fundamentalist Protestant denominations. And that's really unfortunate, because Christianity has a very long tradition of being open to science while not being relativistic.
Yes. And really, I do believe the Bible teaches that when Jesus said in John 10:38, if you do not believe me, believe the works, he's appealing to things outside the Bible as proof of his messiahship. And that extends into creationism and archaeology, if you can extend it there. And like I said, one guy who's appeared on my channel, he was a naval officer, a great warrior, but after he retired, his life was in a bad spot. And then he just heard about, his son took him to church one day, and our pastor, Lon Solomon, was preaching on the archaeology of Hezekiah, related to Hezekiah. And that changed his life. That led to his salvation. So praise God for that. It's just an archaeology lecture. So
I'm curious, by the way, so do you also have theological debates on the channel, or is it entirely apologetic from a scientific point of view?
Almost purely apologetics, evidence and reasons. So one reason for that is there are plenty of channels that, people love arguing philosophy and theology, and there are plenty of channels for that. My channel is, because I have a specialized skill set, it's like that's what I'm going to focus on, what God is, the office where God has put me, which is in the sciences. But I do like archaeology, and I love personal testimonies. So those are so I'd say the four pillars, the three really big pillars of evidence of the Christian faith is evidence in nature, which is creation science, intelligent design. Second would be archaeology. And then at a heart level, personal testimonies, answered prayer, and changed lives. A small bit of presuppositional, not much.
The fourth that I would add is demonstrable miracles and prophecies.
Yeah. Yes.
It's interesting, by the way. What did you want to say?
I wanted to say the fifth thing that we do, and I don't do a lot of it, is difficulties in the Bible. And one of them is the problem of evil. I've had 2 lectures on that. And then the hiddenness of God. So no matter how much evidence I may give someone, we have to address the problem of evil, because I'll never forget, I was with an atheist group, and a young lady came up to me and my friends, and she started crying because some of her friends in the group had said some things that were very insensitive, because it turned out she was a rape victim. And I'm just like, oh Lord, what can I say? I could talk about archaeology or creation science, but how do I help her see the love of Jesus? How can she connect with the love? To have gone through that, it's very natural for someone who's gone through something so traumatic to believe that God doesn't care for them. And that troubled me for a very long time. And I said, Lord, you got to help me with this, because this is a real problem. At a very heart level, this is where people have to deal with things. Even people that want to believe in God, going through an experience like that can be just very challenging to believe that God cares for them.
Yes,
So
that's indeed very interesting. I would say that the problem of evil is probably one of the areas in which Catholicism and Protestantism differ the most, which is interesting because most people wouldn't immediately realize that, but it's primarily just a result of their differing views on faith and works and things like purgatory. That actually has a very subtle influence on how the problem of evil is dealt with.
Yeah. So I had to talk about that, because when there were polls done on people why they don't wish to be believers or not, they will rank the problem of evil as number 1, somewhere in there, like the hidden God, and then that Christianity doesn't agree with science. So those are the 3. But I think the problem of evil, I tried to deal with it in 2 lectures. So basically, one way it can be framed is, why did God let the snake into the Garden of Eden? Why did he let man be tempted? And I gave my opinion on that and related it to Deuteronomy 13. So that's an overview of the channel. I think I need to just kind of bring the stream down. Would you all be interested in meeting tomorrow to do more chemistry?
Yeah, that would
probably.
be great.
I'll have to see if I am able to. Oh, I'm sorry, I hit something. I said I'll have to see whether I'll be able to be there on time, because I have a busy day tomorrow. But if I'm available, yeah, I definitely wanna
Okay.
partake.
I'll James, if Walter likes this, he's welcome to join, and he can email me if he wants to be put on a mailing list, and we can do this. If it's okay, James, we could just, as long as I have one person willing to do this, I'll make the lecture happen. So James, if you want to do this tomorrow, okay, great. So gentlemen, do you have any closing thoughts before I shut down the stream? And I see that One Cow Stampede has joined us.
One closing thought that I actually had was, because we were speaking of like demonstrable miracles and prophecies and how they relate to the problem of evil. I just hope that if anyone here isn't familiar with it yet, people will look up the prophecies of Our Lady of Good Success, from Ecuador, from the early 17th century, just because that prophecy describes the situation in the 21st century, and I think it's becoming increasingly relevant. So if the problem of evil is ever further discussed, I think it would be very useful in that regard. It's just something I thought would be interesting.
I would love to debate with you, Montesquieu, because as a Protestant, I cannot. I don't think I believe it, but we can discuss it one time.
Yes, I think that'd be a great debate for another channel. I don't do that. You see, I'll tell you one thing. I try to keep my channels low drama. I'm Protestant.
Yeah.
And
well,
so
I understand that. That's fine. That indeed would
Yeah.
be something for a different avenue. It's just something I thought of due to the problem of
Yeah,
evil
no.
being
These things definitely have to be discussed and thought about.
Because like Michael Behe is a Catholic and John Sanford is a Protestant, so I think we should keep these. If we within the creationist realm, we should. We shouldn't discuss this because we have atheist enemies already.
Yes. So that's
Yeah.
that's the one thing beautiful about science and the intelligent design movement. We can have very different theological views, but the science is kind of brings us to a neutral place where we can we can accept chemistry, physics, and mathematics.
You can even talk with Jews and Muslims in theory.
Yeah.
Yes,
Yeah.
basically,
Yeah.
as long as you agree on the natural order and how the world works, the supernatural debate can be left aside for.
Yes. And one reason that this is very powerful is we use a lot of what we use for intelligent design arguments is using textbook chemistry and physics, which drives modern technology. Everyone will accept textbook chemistry and physics by and large because it makes the modern world work. And we're able to then have kind of a common ground there. And so I notoriously have low drama channels, and I like to keep it that way. I don't know if you're familiar with the high drama channel. There's Smoky Saint. That's the high drama channel. Oh my goodness.
We should visit it in. That will be exciting.
Oh boy. Oh my goodness.
But thank you for this lecture, and I look forward to hearing more. The scientific approach to this has been refreshing.
Well, let me close in a prayer here. Heavenly Father, we acknowledge you in all our ways. Please bless this chemistry lecture series, and thank you for giving us this knowledge that you help us to understand your creation. Be with us this day. In Jesus' name, amen.
Amen.
God bless you all. Take care. And I can meet you all backstage after I shut down the stream just to say goodbye.
Yeah, that would be great.